Hello everyone, my name is Aarohi and welcome to my channel. So guys, in this video I will show you how to use OpenCV on Jetson Nano. So we will learn how to work with images, videos, and then different cameras, like how to work with CSI camera and then USB cameras like your web cameras, and then how to process RTSP streams. These kind of things we are going to cover in today's class. So let's begin. So the first thing is we need Python installed on our Jetson Nano. So guys, there is no need to install this Python manually, because when you boot your Jetson Nano for the very first time and the Jetpack which you have used, in that Jetpack SDK there is already a Python version. Okay, so in my case I'm using a Jetpack SDK 4.6. so let's see the Python version which we have in Jetpack SDK 4.6. so open your terminal and now we'll see the Python version. Here you can see the Python version is 2.7, but we don't want to work on 2.7. So let's see the Python 3 version. So the Python 3 version is 3.6.9. So this is the default Python version on Jetpack SDK 4.6. And guys, this NVIDIA, they recommend to use the default Python version, so we will not upgrade it. Okay, so otherwise suppose if you want to work with some other Python versions, like you want to work with Python 3.8, then you can install Jetpack SDK 5. Okay, instead of 4, install Jetpack SDK 5, then you will have that Python 8 3.8. all right, so for today's class our Python version is 3.6.9. After having this Python, now the next thing is to install the text editor where we are going to write a code. So the text editor which I'm using is gedit. You can simply install it by sudo apt-get and then install gedit. Okay, so once you install the text editor, the next thing is to install pip. Okay, because pip is a package manager and we will install all the other packages using pip. So first update your apt-get, sudo apt-get update, and then execute sudo apt-get upgrade. After executing these two commands, then you will write a command to install the pip. So we want to install the pip for Python 3, so we will write sudo apt-get install python 3-pip. Okay, so now we have pip installed. Now guys, this is an optional step, but I always work in a separate work environment, so I will create a separate environment, and if you wish to work on a separate environment, then you can follow these 3 steps. Otherwise you can leave the next 3 steps. Okay, so I am installing the virtual env first. And then using the virtual env, I'm creating a separate environment with the name of env. After executing this command, you will get a env folder, and that will be your separate environment. All the packages will be installed in that folder. Okay, so now you create the environment. Let's activate the environment by writing source, then the environment name which is env, then bin, and then activate. Now our environment is activated. So guys, after that we need to install OpenCV. And if you want to see guys, as I've told you in the beginning, that there are some default packages which you get with your Jetpack which you have installed. Okay, so for example, Python 3.6.9 and the Python 2.7.17, these two are already there in Jetpack SDK 4.6. In the same way, OpenCV is also present by default in that Jetpack SDK, but I don't want to use that OpenCV, because that OpenCV was giving me some errors while working on object detection models, so I upgraded the OpenCV version. Okay, so if you want to check your current Python this OpenCV version, then you can execute this command and you can see that the by default this OpenCV version is 4.1.1. okay, and this was, as I've told you, that this particular version was giving me few errors, so I have upgraded it. Now I have Python 4.5.1. all right. Now if you want to learn how to install OpenCV step by step, then you can follow this video, and link is also given in description section. You can check that video. In that video I have explained step by step how to install OpenCV, which is compatible with CUDA also. okay, so now I'm assuming that you have a Python and you have a separate environment and you have OpenCV installed in your PC. Now let's execute the programs one by one. okay, so let's start with the first program, which is this one. Let's open this program and see what is there. Okay, so here you can see first we are importing the OpenCV module, and then we are checking the version. Now in this line you can see that I'm using cv2.imread. imread means to read the image. Which image you want to read? The image which is present in assets folder. There is one image with the name of this. okay, now I've read the image. Now I want to show that image, display that image. So for that we use cv2.imshow. okay, and this is the variable name which we have used above to read the image. And then we are using this wait key. Now this wait key, why we use it? Because guys, if we'll not use it, then your window will open, the image will open and it will close suddenly. okay, so if you want to display the image, and if you want that window should open for some time, then we provide some time over here. 0 means infinity, and suppose if you write 1000 over here, that means 1 second. 5000 means 5 seconds. So this is the time for how much time you want to open that window to display the image. okay, so let's execute this program. Now how to execute this program? So guys, I have told you that I have created a separate environment. okay, so this is my separate environment. I have activated the environment. Now all my codes are there in one folder. Let me show you that folder. okay, so you can see I have created one folder with the name of Python_examples. You can create one folder. Inside that folder I have my code which I'm going to show you today. okay, so we are running this first one. okay, let's run it. So let's enter in the folder first Python examples. Now you can see all my codes are here. First I'm going to run this one. okay, so we'll write Python, then _testing opencv.py. let's execute it. So you can see the Python version, OpenCV version is this, and this is the image. So this is the image we have. okay, so we have successfully executed our first program. Now let's move to the next program. So now the next program is, let's go here. Now let's learn how to work with videos. okay, so let's open this second code here. Now you can see that I have imported the required modules. After that I'm using cv2.video capture. Video capture is used whenever you want to work with videos or cameras, right? Then we provide the source over here. So right now we are working with the video, so I'm giving the video path. Inside our asset folder I have this video. okay, now in the next line we are checking whether OpenCV is able to read that video or not. okay, so for that we have used this cap is open, false means not able to read. okay, so if OpenCV is not able to read the this source, then it will show this error. Otherwise, why we are using while loop? Because guys, see, videos or cameras gives us a series of frames. okay, video is a series of frames, so we want to read all the frames one by one until we reach the last frame. okay, so that's why we are using a while loop. okay, and then here you can see the cap.read. So this cap.read will provide, you know, a boolean output like true or false. So true means that it is able to read the video frames, false means it is not able to read the video frames. Okay, so after this line, if it is true means if OpenCV is able to read the frames, then cv2.imshow, using this we will display those frames. Okay, and if in between you want to you know, exit from that window, then you can press Q and you will be exit. Okay, and otherwise it will work until you reach the end, the last frame. After the last frame, this will break, the loop will break. Okay, so after that we are releasing the video capture object which we have created above. This is the video capture object which we have created, right? So once you see the whole video, displayed the whole video, after that you will release that object and then we will destroy that window. So now let's run this one. Okay, so where is, okay, here is it. So Python 2 underscore this one. So now it will show you a video. See, it will display you a video, it will show you all the frames, and let's suppose if in between you want to exit from this video, then press Q and you will be exit. So this is how you work with the videos. Okay, now the next thing is to work with cameras. Okay, so we are working on Jetson Nano. So with Jetson Nano we can use the CSI cameras also. I'll show you how to use that firstly. Okay, so okay, let me close this, and then this is the code of that. Yeah, so now guys, over here you can see that I am using one module, nano camera. So this nano camera is another module, and what it does is, okay, so yeah, so this is a camera interface, and using this camera interface you can easily access CSI camera, USB cameras, RTSP streams, and it is based on OpenCV. So you can access, you can use OpenCV with it. Okay, so how to install it? So if you want to use this nano camera module, so first you have to install this module. So how you can install? Just pip install nano camera and this module will be installed. Okay, so now once you install it, you can see here that here this is the line. What we are doing is nano.camera. We are creating the camera instance, and inside it these are the parameters we have provided. Okay, so this is how we create the CSI camera object. Okay, so you will write this, and after that over here we are printing, just printing whether the CSI camera is ready or not. So camera is ready will provide you that, and while camera is ready, then what we want to read the frames of that camera. Okay, so once camera is open, camera is ready, what we want to capture the stream of it. So we'll capture the every frame of that stream. Okay, so that's what we are doing over here using this read method. And once you read the frames, we want to display the frames, and for that we are using cv2.imshow, and we are displaying all those frames. And guys, if you want to exit, you can press Q, you will exit, and once you done with it, you can release the camera object and then you delete the camera object. All right, so let's execute this one. Okay, so okay, let me open the terminal, go to the Python examples, and after that our example is 3 underscore CSI. Okay, so this is the command. Now you'll see here, you can see, okay, let me set it. See, you can see the frame is working. Okay, right? So guys, this is how it works. Now press Q. Okay, so you can see this is how you can use CSI camera. Now let's see how to use the USB camera. So for that what you need to do is just change this line. We will comment this line and now we'll add the code here. Okay, just give me a second. So this is the line which I have added. Yeah, so you can see we are again creating the camera object, okay, camera instance, but this time over here we are providing camera type 1 and device type 1. So remember, whenever you are using nano camera interface, then you have to provide the camera type equals to 1 and device type equals to 1 whenever you want to use the USB camera, okay, and then this width, height and FPS. Okay, now that's it. Now we will save it and we will execute it again. Now when you will execute it, you will see the output of USB camera. So let's see here. Okay, so this is how you can use this USB camera. Now the next example is RTSP stream. Okay, now I will show you how to use RTSP stream, and guys, for that I have decided to, okay, before moving to that part, what I want to show you is, just a second please. All right, so over here, so the nano camera module which I'm talking is, it is freely available at GitHub and you can check it. Let's go through it. Okay, so these are the feature of that nano camera, and guys, this is how you can install it. Okay, so for that guys, you can only work with nano camera if OpenCV is installed, and how to install OpenCV, that I've told you to check that separate video which I've done on that. Install OpenCV first, then install this nano camera, and there are two ways to install this nano camera. One is this method and other one is this manual process. Okay, and then you can work with, these are the different things they have explained. You can use multiple CSI cameras also. This you can explore from here. And for the USB camera, as I've told you, use the camera type 1 and device ID is equals to 1 if you're working on USB camera. Now the RTSP stream, I'm not showing you the RTSP stream through this because I think that let's try some other way to process the camera, use the camera. So I'll show you how to work on RTSP stream using GStreamer. Okay, so but before that, just see, if you want to work on RTSP stream, then you only have to make the camera type equals to 2, and this is how, this is the RTSP stream. But while providing the location of this RTSP stream and like this in a variable, there is no need to write RTSP colon and the double slashes. Okay, just give the path like this, IP camera's path. Okay, and then you create the object like this, and camera type should be 2, and the source should be the variable name where you have your IP of RTSP stream. Okay, so this is how you can use this RTSP on it. Okay, now let's see the third one. Okay, the how to use how to access RTSP stream using GStreamer. Okay, so let's see that. Let me close it first. Okay, let's close it, and let's close this also because so many windows are here. Close this as well. Now what we want to try is this testing RTSP. Okay, let's open it here. So guys, first let's understand this code, then we'll execute. So this thing over here, these lines, okay, this is a GStreamer pipeline. So guys, in this class I am not going to explain you what is GStreamer in detail. I have a separate lecture on that. In that I'll cover the depth things. Today basic idea what is it, and then we'll execute the program. Okay, so this is a GStreamer pipeline. So basically GStreamer is a framework, multimedia framework with which you can perform various tasks on audios and videos, and you can perform so many computer vision tasks using this. And in GStreamer we create pipelines. So pipelines are simply the arrangement of plugins, how you want to it is just a how you arrange all the plugins of GStreamer so that you can data can go through it, and all the plugins will do their work. So in GStreamer we have different plugins, and all the plugins have their different tasks. So over here, as you can see, this RTSP source, this is one plugin of GStreamer, and the task of this plugin is to get the input. Okay, this is a input source. So we are basically, what we are doing here, so we are reading the RTSP stream, and this location and latency, these are the two properties of it. Location simply means over here we have provided the location of the RTSP stream, and this is the latency. Okay, so this is the plugin of GStreamer, and then we are using the two properties of it. And then we have a Q simply is a basically a memory, a buffer, where this plugin will store its data, and from here the next plugin will pick the data. Okay, this is what Q does. And our next plugin is this RTP H265 DPay. Now after that we have this plugin, and then we have this plugin. So we are linking these three plugins over here. So what we are doing is this RTP H264 or 65, what they does is they extract the H265 video from RTP packets, and after that this H265 parse what it does, this is a video parser GStreamer plugin, and the task is to parse the H.265 streams. Okay, and then this is a next plugin. The task of this plugin, this is a this basically performs the color format conversion. Okay, and then we have this plugin, and this. So over here what we are doing is we are providing the data which is in this format to a video convert plugin, and now we want to have data in BGR format because OpenCV accepts the data in BGR format. Okay, so that's what we are doing. So after that finally we'll get the data. Okay, so what this whole plugin does, now this is a pipeline of GStreamer. Now what it does, it read the RTSP stream, then it perform all the functionality which is required to perform on that RTSP stream in order to provide it to OpenCV. So that stream should be, that RTSP stream should be OpenCV ready. So we are performing all those processes in between, and finally our RTSP stream is ready to which OpenCV will accept. Okay, so this is what we have written over here. And after that, over here you can see that CV2.video capture. As I've told you that video capture will, whenever you're working on videos or cameras, you use this video capture object, right? Source, what this source is, this source, the pipeline which we have created, and this source have now RTSP stream which OpenCV will accept. And after that here you can see, so guys, I have written the pipeline like this also. There are different ways to execute the pipeline. You can execute the pipeline like this also, and you can execute the pipeline like this also. Okay, so while true mean what we are doing, we are cv2.video capture, we are reading the source, and if stream is opened, then okay, if stream is not open, then source not available message will be displayed. Otherwise you will get source connected, and then you will keep on OpenCV will read the frames. Okay, again this read will give us a boolean output, true or false. True means it is able to read the frames, false means it is not able to read the frames. So if it not, that means it will show you this method failed to read from stream, and if it is reading the stream, then it will show you all the frames. Okay, so this is how it works. Now let's execute this program. So testing RTSP, let's execute it. Python. So this program is, what is the name, for underscore testing RTSP. Okay. Okay, now so here you can see the RTSP stream. Okay, this is our RTSP stream, and now if you want to close it, just do Control-C over here and your RTSP stream will be closed. So guys, this is how you can use different ways. This is how you can use OpenCV with different sources. I hope this video is helpful. Thank you for watching.